what we need to define a few things or examine a few things when it comes to the perfectly competitive firm. The first thing, we review our definition of total revenue, and the total revenue is the total amount of money that a firm takes in this case, price times quantity. Remember that the firm is a perfectly competitor, so the price for this firm is just going to be the market price, whatever that is. If widgets are selling for $10 in the market, then the firm can sell as many or as little as they want at a price of $10. So if they sell 1,000 times $10, their total revenue would be $10,000. Average revenue is the average it takes in for each output. Now, when you sell everything for the same price, the $10 for the price of the widgets, the average revenue is also going to be $10. And the marginal revenue is going to be the additional revenue from selling one more unit of the output. So if I went from selling 1,000 to 1,001, I put an extra $10 in my cash register. So the change in total revenue from selling one more unit is marginal revenue. It's worth noting that a competitive firm we saw on the last slide can sell as much or as little as it wants without affecting the market price. They're a small fish in a big pond. This assumption, this assumption that you can sell as much or as little as you want without affecting the price you can sell for is only true for perfectly competitive firms. For other firms, if they want to sell more units, they could do so by lowering their price. But if they tried to raise their price, they would lose some of their consumers, but not all. Perfectly competitive firms, however, given the assumptions that we've made, can sell as much or as little as they might want to without affecting the market price. It's useful now to think about profit maximization by firms, and we begin by stating something called the equimarginal principle. And this is an important principle in economics that holds not just for competitive firms, but for all firms and for all consumers. In fact, we learned about this when we thought about maximizing utility. If something is worth doing at all, you do it as long as its marginal benefit exceeds its marginal cost, and then stop once those two things become equal. For all firms, this means you produce as long as the marginal revenue of the next unit exceeds its marginal cost. If we can earn more, if we can add more to our cash registers from selling one more unit than it costs us to produce that unit, then we should continue to do so as long as that is true. So for perfectly competitive firms, remember that price is equal to marginal revenue. We can sell as much or as little as we want at the market price. So for every unit we sell, we add P dollars to our cash register. Firms, we know, should produce as long as marginal revenue is greater than marginal cost. And we'll demonstrate this a little bit more rigorously coming up. Now remember, marginal cost for competitive firms rises due to the law of diminishing marginal product. So marginal revenue is a constant, is equal to the product price, and marginal cost rises. Marginal cost will be increasing for firms. We produce then as long as marginal revenue is greater than marginal cost. If marginal revenue exceeds marginal cost, we want to increase our quantity of output to increase our profits. If marginal revenue falls below marginal cost, then we should stop producing it. We should not produce those units that add less to our revenues than they add to our costs. Graphically, here's what we're looking at. Marginal revenue is a constant equal to P1 in this picture, which is represented by the horizontal line, the horizontal red line. Marginal cost is an upward sloping line reflective of the law of diminishing marginal product. And so if we are less than Q1, say we're at QA, you can see that we collect P1 dollars, but the cost of producing that unit is less than P1, so we should sell it, and that will add to our profits. If we're at QB, we can see that the cost of producing that unit is higher than the amount it adds to our revenues, and so we should not produce that unit. In fact, we should produce everything up to unit number Q1, but we should not produce anything beyond there. So if we find ourselves at QA, this would suggest we should increase production. If we find ourselves at QB, we should reduce production. If the price rises, then we just continue to follow our equal marginal principle. So if the price in the market goes up for some reason, if consumer demand rises for all firms, then we see the price in the market rise, and firms should continue to produce where marginal revenue equals marginal cost. If the price goes up to P1, from P1 to P2, this firm should increase output from Q1 to Q2, remaining along its marginal cost curve, again looking for that spot where marginal cost equals marginal revenue. The firm's marginal cost curve then represents the firm's supply curve. Essentially, the firm's marginal cost curve illustrates their relationship between price and quantity. We'll tell you how much they're going to sell at each given price, and remember, that's our definition of a supply curve. There's one more thing that's important to examine from our equal marginal principle. It's worth reviewing the whole thing, but if something is worth doing at all, then you should do it as long as marginal benefit is greater than its marginal cost. So for firms, we produce up until marginal revenue equals marginal cost. But the first sentence is worth examining too. If something is worth doing at all, it's possible that it might be better off to produce zero than to produce where marginal revenue equals marginal cost. So we're going to think about that part a little bit more carefully. We want to define a couple of things. The first one is shut down, and the second one is exit. A firm should shut down in the short run sometimes due to certain market conditions. If the firm makes a short run decision not to produce today, that is a short run decision. In the long run, firms might exit the industry completely and decide not to produce at all. The key difference is that in the short run, firms must still pay fixed costs. You may still have your office lease to pay or something like that. In the short run, you have fixed cost. In the long run, you have zero costs. You can eliminate all of your costs completely. So firms may choose to shut down in the short run, or firms may choose to exit in the long run, and the distinction is whether or not the firms will have to carry their fixed costs or not. It's time to do a little bit of algebra. Recall our formula for profit maximization. Profit revenue is equal to total revenue minus total costs. And we can rewrite that as price times quantity for revenue and split total costs into the variable cost component and the fixed cost component. So profit is equal to revenue, price times quantity, minus total variable costs minus total fixed costs. And if we shut down in the short run, our profits are not zero. Our profits are equal to minus total fixed costs. We still have to pay our fixed costs. So the comparison decision for a firm about whether to shut down or not doesn't depend on, isn't going to be comparing profits to zero, but comparing profits to the loss you would occur if you had to pay your fixed costs anyways. So we should stay open in the short run as long as the first two terms, revenue minus total variable cost, is greater than zero. We should stay open then if total revenue exceeds total variable costs. This potentially could give us a loss, but the loss is going to be smaller than total fixed costs. As long as we replace revenue minus total variable costs with something greater than zero, our profit will be bigger than minus total fixed costs, which is the choice we have if we shut down. We can examine this another way. Profit is equal to total revenue minus total costs, and then multiply and divide total variable costs by Q, which doesn't, so essentially we're multiplying by 1, and so this isn't going to change the value of our formula. And then rearrange terms a little bit, and you can see the last row of our three equations that we've written down. If you look at the term in parentheses, price minus average variable cost times Q minus total fixed cost is an important equation. Recall, if we shut down, our profit is minus total fixed cost. We lose money. But if that term in parentheses, price minus average variable cost, is positive, we're better off staying open, even if we might potentially have a loss. In this case, we should stay open as long as price is greater than average variable cost. So if we can sell each unit for a higher price than it costs us in variable cost to produce that unit, we're better off staying open, even if we can't earn enough profit to cover our fixed costs. In other words, we stay open as long as we can cover our variable costs.